our theorems today. They're not super difficult theorems. They're kind of wordy, and I think really what makes them more difficult than the actual theorems themselves is that they're just really similar. So knowing the difference between theorem 5.2 and 5.3, and then kind of taking that into the next one. So, okay, so starting with theorem 5.2. So theorem 5.2 talks about a perpendicular bisector. So with theorem 5.2, what you're starting with is you're starting with a segment. Okay, so a segment is a line that has two endpoints. Okay, and this segment has a perpendicular bisector, which means that line forms a 90-degree angle with the original segment, but it also cuts that segment in half. So kind of building that picture, and you can see that here, okay? So you have this segment AB. You have this perpendicular bisector. So PM not only creates right angles, but it also cuts AB in half. So AM and BM are the same length. What we're looking at today with this one is we're going to look at point P, okay? And technically, it doesn't have to be point P. It could be any point on that bisector. In this case, point P is right here. But if point P was up here, it would still work. If point P was down here, it would still work. It doesn't matter. Any point on that perpendicular bisector is what's called equidistant from the endpoints. Equidistant means pretty much exactly what it sounds like. Equal, distant, distance, equal distance. So what that means is P is the same distance from A as it is from B. So like what it would look like as a picture, if you actually drew lines from A to P and B to P, you kind of form triangles. Those two segments, those two sides of the triangle would be congruent because they would be the same distance. Okay? Theorem 5.3 is just the converse. When the converse, you just flip it. So instead of starting with a perpendicular bisector, you're going to start with those two congruent segments. So what theorem 5.3 says is we have a point. Okay, so I've got a line, I've got a segment, and I've got a point. Okay, a segment and a point. If this point is equidistant from these two endpoints, okay, so I have this point, it's the same distance from here to here. If that's true, then that point is on a perpendicular bisector. You could draw that line straight down, and it would be the perpendicular bisector, so just kind of going the opposite direction, okay? Now, the reason why this is useful is it kind of helps me establish congruent segments. What you do today, your homework today, is really pretty easy, but I really want you understanding like the why behind. But your homework is going to be doing things kind of like this. So this picture that we have here, we have this triangle ABC, okay? If you look at this segment AC, okay, so we have this segment AC, and what I can tell by the markings is that BD is the perpendicular bisector because it creates a right angle, they tell me that. And it tells me that these two segments are congruent, which means that BD cuts AC in half. Now, since BD is the perpendicular bisector, theorem 5.2 tells me that B, the distance from B to A, is the same as the distance from B to C. These two are the same. Those two sides of that triangle, if you draw those lines, are going to be congruent, which can help me find my value of x, because if those sides are congruent, what do you know about the lengths? Equal. Yeah, they're equal. So I could say 4x equals 6x minus 10. And then you could solve for x, so subtract 6x from both sides. 4x minus 6x is negative 2x equals negative 10. Divide by negative 2, you get x equals 5. A lot of what you're doing today is setting two things equal to each other and solving for x. But the reason why we're setting them equal to each other comes from these theorems. So we really want to make sure that we're understanding why we can set them equal. Okay? Now the next two theorems deal with talking about the distance from a point to a line. So if we're kind of looking at a picture here, this can kind of be hard to think about. So I've got this point here, and then I've got this line. Okay? If I wanted to talk about the distance, so if you're on this point and you want to get to the line, so I might talk about like if you're standing here and you want to get to this road, what you're looking for, you could take a couple different paths to the road, right? You could kind of go here, right? Okay, or you could go here, or you could go here, right? The distance from a point to a line is always going to be the shortest possible distance. Okay, and what that creates is it actually creates a perpendicular line every single time. The shortest distance from a point to a line is going to be the perpendicular segment from the point to the line. That's always going to be the shortest possible distance from the point to the line. Okay, a bunch of different ways you can get from the point to the line, but the actual distance, okay, is going to be the perpendicular segment. Okay, so bringing that into our next two theorems. The next two theorems are talking about angles. So the first two are talking about segments. Okay, I know we had kind of triangles and things in there, but they're talking about segments and the segment bisector. These are talking about angles and an angle bisector. So no, an angle bisector cuts an angle in half, just like a segment bisector cuts a segment in half. Okay, so what theorem 5.4 does is it says I have this angle. So the first angle that I have here is angle PQR. Okay, so I've got angle PQR. And then I've got this angle bisector. So QS bisects that bigger angle, which means these two smaller angles are congruent. Okay? Kind of like with the last one, how I was talking about any point on that bisector is equidistant to the endpoints. This is kind of the same thing. Any point on this bisector is equidistant to the sides of the angle. So these lines right here. So the distance from S to that side is going to be the same as the distance from S to the other side. Now that's why it's important to remember that we're talking about distance from a point to a side. So that should be your right angle right there. But kind of like with the segment bisector, this has to be point S right there. It could be that point right there. But that point right there is going to be equidistant to both sides. It works all the time. Which means these two are going to be congruent sides. Okay? And then theorem 5.5 just does the opposite. So it starts with, okay, I have an angle, and in this angle, I have a point on the inside. Anywhere on the inside, okay? It doesn't have to be right there. It could be right here. It could be right here. But I've got this angle, and I've got a point on the interior, on the inside of the angle. If this point is equidistant from both sides, this point has to be on the angle bisector. So just kind of going the opposite direction, okay? And we can use that to help us solve for some missing sides here. So like this one right here, okay, I have this big angle, angle L in Q. I know that ray in R bisects angle L in Q. I know that it bisects it because it tells me that those two angles are congruent. Okay? Since this is an angle bisector, what that means is every single point on that angle bisector is going to be equidistant from the sides. So if I were to pick a point on the angle bisector and find the distance to the sides, it'd be the same. These two segments are the same. So what they did here is said, okay, I've got point R here. Here's the distance from R to that side. Here's the distance from R to that side. Theorem 5.5 tells me those two are the same. They're congruent. So if this is 7x and this is 2x plus 25, I know that 7x equals 2x plus 25. And then we can solve for x. So subtract 2x from both sides. 7x minus 2x is 5x. Divide by 5, we should get x equals 5. Really, honestly, guys, this is about all you're doing today. Solving, but like I said, I want you to understand why we set them equal to each other, how to use the theorems going from there. Okay? Alright, so this should be glued into page 67. This is section 5.2, and it is perpendicular and angle bisectors. Alright, so we got some art skills today, some nice drawings. So, here we go. We have only three triangles to draw. So let's first draw like a little sideways triangle like this. Okay, with something like that. This top vertex is going to be A. That left is going to be B, and this bottom is going to be C, and then that middle is going to be D. And then also marked on this picture is going to be this right angle, and then the AD is congruent to CD. You're going to be doing a couple different things in your homework today, but I really, really want you kind of understanding what information you're given, and because you're given that information, what else do we know about some of the other segments, angles, things like that. Okay? So, I'll give you some more information once we kind of get into this, but looking at this picture, the first thing I want to know is what is the relationship? What is the relationship between BD and AC? What is the relationship between segment BD and segment AC? So I'm highlighting those. Segment BD would be that one right there, and segment AC would be this one right here. What's the relationship in those two segments? They are perpendicular, right? Because that's a right angle, which means, of course, this has to be a right angle too, okay? They are perpendicular. What else? They do cross, they do intersect. Now, when they intersect, they do something special. They bisect that. See that? That when BD comes down and it's perpendicular, but it also cuts that in half. How do you know it cuts that in half? Okay. See that those are congruent? So if we want to be really specific, what we would say is that segment BD is the perpendicular bisector of AC. Now, since it is the perpendicular bisector, this brings in one of our theorems. It's going to be that first theorem, theorem 5.2. Okay, the perpendicular bisector theorem. The perpendicular bisector theorem says that if you have a perpendicular bisector, any point on the perpendicular bisector, any point here, right here, right here, right here, right here, any one of these points is equidistant to the endpoints. So if I have this point right here, this point is going to be the same distance from A than it is from C. This point is the same distance from C than it is from A. Those are going to be the same anywhere on the perpendicular bisector. And those are nice and all, but they actually gave me a point, right? B is on the perpendicular bisector. And since B is on the perpendicular bisector, that means B is the same distance from C, then B is the distance from A. So what do you know about those two segments? they're congruent. So we can mark that they're congruent. Okay, now, to kind of go a step further with this, other information they're going to give you right off the bat, but I'm not going to do that because I want us to think and use our brains. If this side is 5x, then this bottom side is 2x plus 9. Number 2, let's find x. How are we going to find out what x is? Theorem 5-2. So what are we going to do? Exactly. We're going to set them equal to each other. We're going to say 5x equals 2x plus 9. Because remember I said those two segments are congruent. They're equal, right? Their lengths are equal. So we can solve here. We can subtract 2x from both sides. So we have 3x equals 9, which means x equals 3. And then the last thing we want to do with this lovely picture here, I want to find BC. Find BC. Now remember, I didn't put a line over BC, so I'm not talking about the segment BC. I'm talking about the length of BC. How in the world am I going to find the length of BC? Plug in. We know what x is. X is 3. So we take 2 times 3 plus 9, which would be 6 plus 9, which would be 15. I didn't ask, I'm not going to ask you this, but I'm going to write it down. What if I asked you, what's AB? 15. Right, same thing, right? Because they're congruent. They're the same thing. Okay. Questions on those first ones? All right, another picture here. Okay, so we're going to have this big angle, okay, and this big angle is going to be angle A, B, C, and then we're going to have this ray here with point D on it. And then we're going to have segments from D out to the sides to point E and point F. And E is going to be a right angle and F is going to be a right angle. The reason why they tell you that, why is it important that that's a right angle? I don't necessarily know yet that it's equidistance, but I know it's the distance, right? I can talk about the distance from D to that line because it's the perpendicular segment. That's why. That's why it's important that it's a right angle. Now, if I were to mark these, then I know that it's equidistant. Okay, now this one, okay, this is actually theorem 5-5. Okay, this is theorem 5-5. Because what I have here, okay, is I have an angle, right? I have a point that is equidistant to the sides of an angle. Okay? If I have a point that is equidistant to the sides of this angle, what does theorem 5-5 tell me about that point? It's on the angle bisector. Yeah. If this point, and the point doesn't necessarily have to be right there, it could be right here. But if that point is equidistant from the sides of the angle, it means that that point is on the angle bisector, which means those two angles are congruent. So, if I were to tell you that this angle in here is 6x, and then this angle in here is 10x minus 16. For number 4, how would we find the value of x? Okay.
6x equals 10x minus 16.
Very good. Right. So we said that those angles are congruent. So it means that they are their measures are equal. So it'd be 6x equals 10x minus 16. So we're going to move our x's to the same side, subtract 10x. So we have negative 4x equals negative 16. So x equals 4. Okay, then number 5, let's do one more thing with this diagram here. I want to find the measure of angle A, B, D, and the measure of angle A, B, C. I want to find both of those. The measure of angle A, B, D, and I want to find the measure of angle A, B, C. So let's start with the measure of angle A, B, D. How will I find the measure of angle A, B, D? Yeah, we know what x is, right? So that angle measures 6x. So we're going to take 6 times 4. So the measure of angle A, B, D is going to be 24. Now, if I want to find the measure of angle A, B, C, that's the whole angle. You are correct. Is there any? Without even plugging that in though, could you tell me what that angle equals? If this angle is 24, what does that angle have to equal? 24. Yeah, also has to equal 24, so you totally gave it, you're going to get 24. So if they're both 24, what is the measure of angle A, B, C? 48, very good. Very good. Okay, one more example. This picture's not quite as hard to draw as the last one. Okay, so this one, I'll have a little sideways angle here. Okay, and we're going to have an angle bisector. Doesn't look like an angle bisector, but it is. Okay, so we'll have B, C, D, and then F out here. Go out this way, and those are right angles, which remember is important because it tells me that the distance, this is the distance from F to the sides. And I told you, doesn't look like it, but this is an angle bisector. Doesn't look like it, but pictures can be deceiving. It is the angle bisector. Okay, before I give you the rest of the information, let's talk about what we know and how we know it. If, because they tell me, right, this is the angle bisector. I know these angles are congruent. What else do I know? I know that those are congruent because I know that any point, it doesn't have to be F, it is F, but any point on this angle bisector is going to be equidistant to the sides. So, since I do have point F, those two are going to be congruent. So, if I were to tell you that BF is 6x plus 3 and FD is 4x plus 9. For number 6, I want to find FB. FB. So I am wanting to find this. Now, in order to find FB, what do I need to know first? I don't know what X is. How are we going to find out what X is?
6x plus 3 equals 4x.
There's yeah, over here a little bit. Yeah, remember we said that these are going to be congruent segments, which means they are equal measures. So 6x plus 3 equals 4x plus 9. So subtract your 4x from both sides. So we have 2x plus 3 equals 9. Subtract 3. We get 2x equals 6. So x equals 3. I almost circled and boxed my answer, but that's not my answer. They don't ask me what x is. They ask me what FB is. How are you going to find out what FB is? Plug it in right here. 6 times 3 plus 3, which is 18 plus 3, which is 21.